Hi guys, Mrs. Valdivia here. We're going to be going over chapter 14, titrations of our lab. So in this one, our learning objectives is to carry out a titration using sodium hydroxide as a base and a burette. So this is an experimental analytical way of determining the concentration of an acid. All right. So we need to recognize that what an endpoint is, calculate molarity of an acid, and calculate the percent by mass of acetic acid in vinegar solution. All right, so let's go ahead and get started. The first thing we want to know is a titration. What is it? A titration is basically an experimental method used to determine the concentration of an unknown solution. And this experimental method gets used a lot in labs when we want to determine the concentration of facial creams, medicines, sunblocks, makeup, anything that you can think of, hair dyes, right? We don't want to put something on our skin or our body, ingest anything that has a very high concentration of an acid or of a base, right? We want to keep things good and steady for us so we don't get hurt. Right? So in titrations, the titration identifies the endpoint. Titration identifies the endpoint. Okay. And so basically the endpoint, this section right here, is when in your solution it is no longer acidic and it has now just started to turn basic. When solution is no longer acidic and has just turned basic. And when I mean it just turned basic, like by one drop, okay? By one drop. Now, what comes before the endpoint is the equivalency point. And the equivalency point basically is when moles of your acid equals the moles of your base. Okay. Now, the reason why we calculate endpoint and not equivalency point is because this right here, we can't really see it. It's almost instantaneous. When it does happen, you have to get like the perfect quantity of acid to base, right? So it's very difficult to get to this point. And we can see the endpoint. And we see the endpoint because the endpoint in a titration is a super faint pink color. So it's a faint pink color. And this is usually one drop after the equivalency point, just one drop. And it makes the difference between equivalency point to the endpoint. And we stop at the endpoint. When you go above the endpoint, your solution is no longer a faint pink, but it actually turns into a dark magenta, similar to this color of this pen. Okay. So how does the titration work? Well, in your titration, you're going to have an acid and a base. This right here is my Erlenmeyer flask, and inside of my Erlenmeyer flask, this is where I'm going to put my acid of known quantity. I have to know how much, and I'm going to have my indicator in here. And because we're trying to indicate the base change, we're going to use phenolphthalein, because phenolphthalein turns light pink in when it starts turning basic. So we have acid plus indicator, and the indicator is phenolphthalein. That's a T, phthalene. And it's going to be clear in the acid. Once you titrate and you add enough sodium hydroxide inside of here, you're no longer going to have your acid and indicator per se. You're going to actually reach your endpoint. And the endpoint is going to be a very light, faint pink color. Which, I was trying to see if I had a little light pink color, but I don't. All right, so it's just a very light pink color. So it's going to be a pink color. And that's going to be the endpoint when you reach that endpoint. And this one is clear. It's clear. All right. Now, inside our Erlenmeyer flask is going to be a burette. And this burette has our base inside of it. And we're going to be throwing the base in here, or dripping it down actually into your acidic solution, drop by drop. Now, a burette has calibrations in it similar to graduated cylinder. And as the graduations go down, you're able to see how much of your sodium hydroxide you're using. So in here is going to be our solution of sodium hydroxide going into our acid. Now the sodium hydroxide, this is of known molarity. We know the molarity. We know the concentration of our sodium hydroxide. We just don't know how much we're going to use. For our acid, in this case, we're going to be using acetic acid. We don't know the molarity. So it's an unknown molarity. But we do know how much acid we started with. So it's an unknown molarity with a known volume. This one's a known molarity with an unknown volume. Kind of like that M1 V1 equals M2 V2 kind of scene. Just saying, right? So it goes down, and your the sodium hydroxide solution, you start dropping it inside your acid and you swirl it. Okay, so you have to swirl it with one hand, and the pink starts going away, right? It goes away, it goes away, it goes away. And then when you notice it starts getting harder for the pink to go away, you're going to slow down the flow. Okay, so if you were doing drop, 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 now you're doing drop, 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 right? You slow that flow down, you keep swirling it, and then the minute that one drop makes it light pink and it doesn't swirl, you turn off the burette. So you basically turn this little knob right here and prevent any more of the base from going into the acid. All right, so how do we do calculations? Well, molarity is the form of concentration, and that's what we're looking for. So we're looking for molarity of acetic acid, and that molarity is going to be moles of acetic acid divided by the volume of the vinegar. Vinegar, acetic acid. Well, vinegar is the aqueous form of acetic acid. Okay, so acetic acid is known as HC2H3O2. If you take acetic acid and you add water to it, you're going to get vinegar. Okay, so a certain percentage of vinegar is going to form. Now, your solution that we talk about with unknown concentration, okay, a solution of unknown concentration, that's going to be your analyte. So this acid right here is going to be our analyte. It is the substance of unknown concentration. We don't know the molarity of it. And the base, because we know the molarity of it, is the titrant. That one's going to be called the titrant. Right, now that we have this down, let's go ahead and go into calculations and how do we do certain calculations. All right, so it tells us to rinse, prepare everything, and how to read a burette. If we look at the burette, it starts with 16, 17, 18, 19, 20, right? It keeps going down. This is the quantity that you have used so far, okay? So how much of it have you used? When you read your burette and you state, well, I've used ... This is how much I've used. Okay, so it would be 20 point something in this case. Okay, you've used 20 point something. Okay. Oh, sorry. I said that wrong. I said it wrong. It took me a moment to think about it. I'm like, no, I did that wrong. All right. So the 19's right here. And as you go down, this is 19.1, 19.2, 0.3, 0.4. And then you go down to 20, and then you go down to 22, and so forth. So this is going to actually be like 19 point something else. If I could zoom in, I'd be able to see the number. However, from here, you could see that we have three different reading types: 19.42, 19.3, and 19.22, right? All depends at which angle we're looking at this from, right? From my angle, the screen is above my eyes, so I'm reading actually like 19.22. If the screen was at my eye level, I'd probably be able to see the 19.3. And if I was reading from above, I'd probably see 19.42. So always good, make sure it's always at your eye level whenever you're reading something with the meniscus. This also includes your graduated cylinders. Right. The vinegar comes prepared basically, so we don't have to worry about that. It tells us how much we use. All right, so the first part says, once we completed the titrations with volumes within 1 milliliter of one another, average the values and perform one set of calculations. So calculate the volume of sodium hydroxide used to neutralize the acid for each trial. This is the final volume minus the initial volume, both in milliliters. Okay, so how much volume of sodium hydroxide was used? So this comes from the burette. Your readings from the burette. You're going to take the last reading minus the initial reading to figure out how much you actually used. I'm going to pretend that I used 25.00 milliliters. Okay. Now we want to convert milliliters into liters of sodium hydroxide. That's question number 2, milliliters to liters. And that is going to be using our conversion factor of, in 1 liter, there is 1,000 milliliters. So you're going to take your number, which is the 25 milliliters, and you're just going to divide it by 1,000. And then that's going to give you your liters. So that's 1, 2, 3. That's in 0.025 liters. Next part is we want to calculate the number of moles of sodium hydroxide. So the moles of sodium hydroxide is going to equal to the volume times the molarity of sodium hydroxide. So the volume is this one right here. The volume is 0.025 liters. However, what is the molarity of this? How did we know what the molarity or the concentration was of our sodium hydroxide? That's actually was given to us up here somewhere. We just got to find it. Hopefully I'll find it for you guys. Here it is. So the concentration is given to us as 0.1 molar. Okay, so it's 0.1 molar. Okay, this allows liters to cancel out with liters, and that gives us moles, and that's exactly what we want. So I'm not quite sure what this equals, so I'm going to put it in my calculator, 0.1 multiplied by 0.025, and I get 2.5 times 10 to the negative third moles of NaOH. Okay. You notice that all we're doing is stoichiometry in sections. That's all we're doing. Okay, now we're going to find the moles of acetic acid. So we're going to go from moles of A to moles of B. So moles of one thing to moles of another. So we're starting off with our 2.5. And now what we have to do is multiply it by the mole-to-mole ratio. And I believe it also gave us the equation that we need on the chart. Right here. Okay, so sodium hydroxide plus acetic acid, if we go through it all, it's all a 1-to-1 ratio. So it's just 1 mole of my base over 1 mole of my acid. That cancels out with that one. Actually, should have been acid, and this should have been base, because this is base. Okay, those cancel out, and we're left with moles of our acid, which just happens to be the same exact number in this case, and this is of acetic acid. All right, last but not least, we need to calculate the molarity of acetic acid using the volume and our molarity. Okay, so molarity is equal to the moles of acetic acid, which we calculated as 2.5 times 10 to the negative third, divided by the volume of acetic acid that was used. So let's find out how much acetic acid we used in this problem. Ooh, excuse me, I apologize. Oh, 5 milliliters. Oh no, this is of the base. We don't want that. We didn't use that. So let's keep going. There it is, 5 milliliters. All right, so we measured 5 milliliters. So we're going to take this and divide it by 5 milliliters, which is the same as 0.005 liters. 1, 2, 3. 0.005 liters. And let's see what that gives us. I'm going to take the number here and divide it by 0.005. And I get 0.5 molarity of acetic acid. And that's all just doing basic calculations, stoichiometry. However, they broke it down into sections, which makes it a little bit easier to understand and actually be able to work on and do. Now that we found the molarity of our vinegar, we're going to go to the last section. And the last section that we have is the mass percent of acetic acid in vinegar. So this one is mass percent of acetic acid in vinegar. So to find the mass percent, the first thing that we need to do is we need to find the actual mass. We don't have that. We have moles, right? And so what we need to do is we need to take our moles and turn moles into grams. So that's going to be our first step, is turn moles of our acid into grams of our acid. Now, luckily for us, it gave us the molar mass already, the molar mass of 60.01. So we're going to take the moles of our acid, which we found as 2.5 to the negative third, 2.5 10 to the negative third, and then we're going to go ahead and multiply this by the molar mass. So this is moles, grams per mole. And the molar mass they gave us was 60.1 of our acetic acid. Moles cancel out, so I'm going to now take my 2.5 to the negative 3 and multiply that by 60.1, and I get 0.15025 grams of my acetic acid. That's what's given to me. Right, now that I have that, the next step is to find out the mass of my vinegar. Okay, so I need to find the mass of the vinegar. So this one was of acetic acid. Okay. So to find the mass of my vinegar, it says that I'm going to take my volume of my vinegar times the density of vinegar. And it wants us to assume that the density of vinegar is the same as the density of water. So let's go ahead and find the volume of our vinegar. We used 5 milliliters. So we had 5 milliliters, and we're going to go ahead and multiply that by 1.000 grams per milliliter. Milliliter cancels out, and we are left with 5 grams of vinegar. And then the final and last step right here is to calculate the mass percent. So we're going to calculate mass percent of, was it vinegar? Or no, of the acetic acid. Acetic acid. And we're going to do that by taking the mass of the acetic acid, which we found here, and we're going to divide it by the mass of the vinegar that we found there. So it's 0.15025 divided by 5, and then we're going to multiply that by 100. So take this number, divide by 5, and I get 3.00%. So I hope you guys are able to actually see that and follow along with me as we do the problem. And yeah, that's it for the lab, you guys. All right, take care. Make sure you use your own numbers that is given to you in the lab so that you can get it correct, and show your work so that you can get full credit. Ciao, you guys.